As David said, I'm from Braintree. We make payment processing really easy if you don't know anything about us. But the most important thing today is that we use Postgres quite a bit. And so that's why I'm here to talk to you today. Cool. What is HA, or high availability, and why do we want it? I think most of you are probably familiar with the concept, but I just thought it would be good to get some definitions out of the way early. High availability means a lot of different things to different people. Some see it as a minimum level of operational performance. However that's measured. Here's a definition that I found that I thought was pretty decent, and it really speaks to what we mean, or to what we take it to mean at Braintree. Here this says, high availability refers to a system or component that is continuously operational for a desirably long length of time. Availability can be measured relative to 100% operational or never failing. A widely held but difficult to achieve standard of availability is, for a system or product, is known as 5 nines. 5 nines, if you're not familiar, which I'm sure you all are, is 5.26 minutes of unavailability per year. So it's a pretty high standard. So anyways, moving right along, some figures. Just yesterday, we actually published some numbers. It looks like we're on track to hit 50 billion in total authorized transaction volume this year. If you average that, that means that for every minute that we're down, we're losing out on something like $95,000 in transaction processing volume. Minimizing any sort of downtime obviously is paramount for us. So that's why we want it. As I was researching, what HA means and such, I found a site that came up with a pretty good definition of how you should go about designing for high availability. And the first of those principles was, detecting failure reliably and quickly. So for us, for operators of Postgres, that could mean anything from, can I connect to the database and run a trivial query? It could mean something more complex, like can I run a query and validate some of my data? And you could even get more sophisticated and measure, say, the performance of the box and take potentially some action on degraded performance even. Those are just some possibilities, definitely just food for thought. Single points of failure. Another big thing that you want to do when you're designing for high availability is eliminate all your single points of failure. Postgres, right out of the box, actually gives us the most basic piece for eliminating single points of failure via streaming replication, and more specifically, synchronous replication. Postgres allows us to ensure that if our master becomes unavailable, all writes that have been acknowledged to the clients have been written to a second database server, meaning that we've at all times have a consistent copy of our database, ready to roll. So for the purposes of this talk, I'd like to scope failure to mean something like a kernel panic that would stop our primary or our standby completely in its tracks, just for the purposes of this talk. The third and final piece is reliable failover. You might think that it's crazy to entrust failover and promotion of your standbys to robots. Others have definitely been bitten by edge cases around this. At Braintree, on the contrary, we believe that with automated failover, we can cut the time that it takes to page out an engineer, wait for him to wake up, get logged in, and take whatever action needs to be done. We can replace that with a system that can take a very tightly controlled series of steps to recover and promote a standby as quickly as possible. So, this is a quote from Postmortem that was published a few years ago by a pretty well-known company. I'm not going to name the company because honestly, it doesn't matter at all. You should also, also take note of the fact that they were reeling from some pretty tough outages. So it says here that the automated failover of our main production database could be described as the root cause of both of these downtime events. We've made changes to our Pacemaker configuration to ensure that failover of the active database role will only occur when initiated by a member of our operations team. I have no idea if they're running this way today, but I would just like to talk for a few minutes about how Braintree attempts to mitigate any sort of edge cases around failover. So we have three big principles. The first one is that there's always just one candidate for failover per database cluster. Each master has one synchronous standby, and there's absolutely no election or other decision making here. As soon as Pacemaker has detected failure, it's authorized to promote the one standby target. The second of these is no flapping. Failover is always only a one-way operation. We can promote a synchronous standby into a master role, but Pacemaker is never allowed to touch a failed master. And then finally, we configure Pacemaker to freeze if it gets confused and it can't make a decision about what to do next. There are some things that you can tweak in Pacemaker to allow it to, for instance, shut down all the resources in a cluster and restart it if it can't get to a known good state. We actually have it just freeze if that is ever the case. So I'd like to dive into the nuts and the bolts of how we actually use Pacemaker and CoroSync at Braintree. Maybe it'll give you some food for thought when you're implementing your own system. So I'd like to start by just running over our topology. As I mentioned, each Pacemaker cluster only consists of a master and slave pair, like a master and a standby pair, for one Postgres cluster. We make sure that for every Postgres cluster, they run in their own Pacemaker cluster just for maximum isolation. We try to achieve even more isolation by running CoroSync, the heartbeat mechanism between Pacemaker nodes on its own network VLAN. We introduced a third server to protect against split brains. This is labeled here, I think, as example quorum. This box is not capable of running any of our databases and is there to simply provide a vote for quorum purposes. At Braintree, we don't do this yet, but you can, in fact, manage a cluster with chain replication in Pacemaker, so you can imagine that quorum box going away and being replaced by a fully fledged database server if you choose.
So that member is part of the cluster, but no resources are allowed to move to it?
That's correct. And actually, I'm going to show you in a few minutes how we manage which resources should run where, and you'll see that it's primarily to keep the database from running on or attempting to run on the quorum box. So anyway, so this is a pretty busy diagram of Pacemaker internals. There's a lot going on here, so I'm just going to explain it piece by piece. Let's see if this pointer works. Yeah? OK. So at the bottom of the stack here, you have the communication layer, and you can choose your stack with Pacemaker. We've chosen to use CoroSync, which is a derivative of OpenAIS. CoroSync provides membership, so a list of peers, messaging, the ability to talk to processes on those peers, and quorum. Moving on from there, the CIB is the next piece in this puzzle. The CIB stands for Cluster Information Base. This is actually where all the definition for all the cluster options, nodes, resources, the relationship to one another, and the current status of everything all of those are stored in the CIB and synced via CoroSync. From there, we have the next thing that I'd like to talk about is the P engine, policy engine. This daemon actually computes the next state of the cluster based on the current state and the configuration that you have. It produces a transition graph containing a list of actions and dependencies. Two other pretty important pieces here are the stoneth-d and lrmd. I'm just going to start with a couple of definitions for stoneth. In case you don't know, stoneth stands for shoot the other node in the head. This is used to fence nodes or sideline them, meaning that they can't talk to anything anymore when they've gotten into a bad state. The LRMD stands for the Local Resource Management Daemon, and it actually just it interacts directly with the resources that you're trying to manage. So in this case, Postgres or virtual IPs. There are a set of scripts that I'll talk about more in a moment that this daemon calls. So resources, they're controlled by OCF scripts, which are kind of like init scripts. They're required to support 4 actions, although they can sometimes support more. They support start, stop, monitor, and metadata. Metadata provides information about the resource in an XML format. I'm actually not too familiar with that last one, but the big ones are definitely start, stop, and monitor. So we use the PGSQL resource. Well, actually, we have 3 categories of resources that we're managing in a Postgres environment. VIPs, so virtual IPs, we use them so that our applications don't have to be aware of the failover. If a master or if a standby is promoted, the IP address of the master moves to it, and our applications can continue processing. So the PGSQL resource. We also have stoneth resources. We have this custom resource that fires SNMP packets to our PDUs to shut off boxes that are misbehaving. Everyone, depending on their environment, is going to want to do this differently. And then the PGSQL resource is the real key one. It's essentially, in our environment, just responsible for answering the question, do I need to fail over? And if I do, I need to fence the old master. It manages also synchronous replication. So this is a kind of an opinionated decision that we've made, but you should obviously do whatever makes the most sense for your business. But in the event that the synchronous standby has issues, you have to decide for yourself whether or not you want to block replication. For us, our setup, in our setup, we monitor the standby, and if it's not safe for the primary to have it in synchronous replication, we actually remove the standby from synchronous replication names. Again, this is totally something that you should decide for yourself, though. So I'm going to make your eyes bleed for a minute. Sorry. But actually, everything in the CIB is XML-based. So this right here is an example of how we configure our virtual IPs for our Postgres clusters. This actual config is derived from what we actually use in production. But in any case, I mean, there's a lot going on here, so you can check the slide later. But the thing that you should really note is at the bottom here, you can configure timeouts for these resources, and you should configure whatever makes sense for you. We use 60 seconds. So the next bit of configuration that I'd like to show you is the PGSQL resource. The PGSQL resources, they represent the cluster themselves, the Postgres cluster themselves, and manage it. In the middle of this document, you can see that we have configured a number of attributes that the PGSQL resource script needs to know in order to operate Postgres. These are things like the location of the binaries, like the PGCTL binary, pSQL, the location of your data directory, and things like that, that it needs to start and stop the cluster, for instance, and monitor it for that matter. We've configured timeouts for all the actions that Pacemaker might take. We've just chosen values that we believe make sense for us. Let's see here.
Can you describe what the timeout applies to?
Sure. So let me take a look at I actually can't see it on my laptop here. So let's take, for instance, this 7-second monitor timeout. This timeout applies to I'm sorry, this is a 60-second timeout. It fires every 7 seconds. So a monitor will fire on a primary or a standby, and in our environment, what it does is it'll connect and it'll do a select one. And if that's successful, great. If it takes more than 60 seconds, then we've detected failure, and Pacemaker initiates a failover, or kicks the synchronous standby out of, synchronous rep. So, does that answer your question? Cool. Okay. So, and then finally, this is our configuration for Pacemaker constraints, and this gets back to the first question of how do you make sure that the database won't run on the quorum boxes? That's essentially all this config does. It's making sure that that we don't attempt to run the database on a box that's not equipped for it. That's there just to provide quorum. In our old environment, we had multiple Postgres clusters in a single Pacemaker cluster, and this file was a lot more verbose back then because we had to make sure that, for instance, like our first Postgres cluster wouldn't attempt to run on boxes that were dedicated to our second. But today, it just forbids anything from running on quorum. This is an example of a Stoneth resource. I pulled this one actually from the docs because I had mentioned that we use a custom rolled one that won't be relevant to any of you really. But commonly used strategies are fencing misbehaved boxes via the PDUs, via shutting off the power to the box entirely, forbidding it from the network at the switch. The most important thing to really think about here is that you want Stoneth to happen externally to the box. You don't want it to rely on something that has to run, for instance, in a shell on the box because it may not even be responsive. In the case of a kernel panic, you wouldn't be able to. Just things to think about.
But in a network isolated case, it would also not possibly run, right?
Could you clarify?
Well, so if you think about having, the two guys and even the witness in a third, place, right?
Right.
If you have application servers talking to your database, right? Your database still may not go away because the guy's trying to command it to kill itself may not get the signal as well, right?
That's right. That's exactly why we want to do this out of band. Right? I may not be.
Depends on what your network. I'm just saying, like, it's tougher than it sounds to do that in a reliable way.
Yeah.
Most fencing, good fencing, occurs actually doesn't allow things to continue to happen on the node. So there's actually control at that level as opposed to, like, you don't want I/O to happen, you don't want networking to happen.
Right.
It's a little different. It's not killing the other node; it's actually killing yourself.
Right. That's a good point. In any case, that actually sums up my explanation of how we use Pacemaker at Braintree, and I hope that these simple examples are useful to you if you are considering trying to maximize your availability with something like Pacemaker. Any further questions? Sure.
Sure. So I like the kill the power of the box solution. That's pretty good. But did you consider anything else and arrive at that after maybe other things didn't work, or did you go straight to that solution from day one?
I think that actually the network solution that I had mentioned, like actually turning it off at the switch, was something that was considered. Actually, the Stoneth piece was implemented before I got to Braintree, so I don't know all the details behind how that decision was made. Dave, maybe you have more context. What's that? It's a very that's kind of that's a huge cop out. I feel bad.
We a long time ago opted to one of the other nodes. So the node itself isn't saying kill myself. Another node participant in the cluster says, we collectively have voted that you're problematic and you need to go, right. And so we'll power it off with the PDU.
Yeah.
Right. So,
but
we did consider cutting off the network, the application VLAN at the switch, right. So that then the box was up for
That's correct. We do have to intervene manually with the master, but if
the box comes back up, you're not suddenly got a locked database running around.
that's
That's right. Pacemaker is the only thing that's permitted. I mean, or a human operator on the box.
right.
Pacemaker starts up the database for you, and Pacemaker is not allowed to start a database on a failed node.
Yep. Yeah, that goes back to my initial point of only letting Pacemaker do one thing, and that's do the actual failover. It doesn't touch a failed master when it comes.
Any attempted graceful shutdown?
We do actually. I had meant to hit this earlier, and I don't know why or where the notes went on that one. But we do try to do a fast shutdown, and if that fails to happen within a certain time frame, we do an immediate shutdown. We do try to shut down gracefully.
But that's also, I mean, in the times over the past several years that this is fired because the box was kernel damaged or something like that. Yeah. So it was immediately shut down anyways.
I think that goes in chorus sync, right? Though the try to do the fast, go try to do the immediate. Because I was looking at some of this recently, and then it tries to do a kill after that, like a kill -9, which isn't ideal.
Oh no.
It does an immediate stuff.
Yeah, we don't do any sort of kill -9.
I think even Kill-9 is safe, right? You kill the, what is it, Postmaster?
I don't know about
I
that.
remember reading that on the web.
I don't think that's safe.
And how do you have the synchronous replication configured? I'm not that familiar with the synchronous stuff. I don't remember the.
You mean it's entirely a Postgres config.
I know, but I'm just. So is it configured that it continues to write locally if the secondary is not around?
If the secondary doesn't accept writes, it doesn't acknowledge writes to clients.
Okay, yeah.
So
You got blocks, that block.
yeah.
For like planned outages, like upgrades or stuff, do you leverage it to move it to a different node temporarily, like upgrade?
To move. Yeah, do we leverage? The question was, do we leverage Pacemaker to promote masters? We do actually.
While you upgrade to minimize.
There are command line tools that you can use to operate Pacemaker, or for just that reason. We actually have a pretty complex set of Capistrano scripts that we use, but yeah.
If CRM standby the primary, which is a native Pacemaker thing, like that node then becomes, from Pacemaker's perspective, offline, and then it will find another place to run the primary resource.
Yeah. So we actually, before we do that for planned maintenance, we actually pause traffic with PG Bouncer, so that we don't take downtime doing that failover for maintenance. So. Okay.
With streaming replication or I missed that part. Only with streaming replication?
Yeah, we only use streaming replication. I'm not aware of using it with something like, I don't know, Londist.
Sync is only supported on streaming, right?
Yes.
So that would work for upgrades. You can't stream to a different version.
Well, you can't replicate to a different version.
You can do a minor version.
Minor version upgrades, yeah. So we actually we're going to have to embark on a project to upgrade to 9.5 eventually, or 9.4 depending. So that'll be interesting. Yeah. I mean, by the time we get around to it, we'll at 9.5 will be.
9.4 is great if you're doing NetDB, but probably 9.5 is more worth the upgrade. I usually almost always skip a major version. Just scheduling the downtime.
Yeah, you have a question?
Yeah, have you guys looked at the DRBD stuff where you can replicate?
We have, and in fact, before we were on 9.1, I believe we did use it, right?
That's correct.
That's how we did sync. That's how we did replication in the past, was using DRBD.
We did, but we also did something a little bit goofy. To facilitate cross data center replication, we used stacked resources, and those turned out to not be quite as robust as we had hoped. So there were multiple motivations for getting off of DRBD and switching to streaming, not the least of which being, hey, we want to query this thing. But
Any other questions?